Okay, so part of compound interest is looking at what we call the annual equivalent rate. So when looking at the formula for finding compound interest, we know that that letter I represents the rate of interest for a year. Okay, and for any period. So we're looking at a year, and usually with the formula that is what we're considering. Our time t was the time in years as well. So I is a rate of interest for a year, and this can be called our annual equivalent rate, or AER. So sometimes you might see it written as that either, and essentially it's the rate that interest would have to be applied at for 1 year to give that particular value. So if we're given the rate for a different length of time, so for example months, or the rate over more than 1 year, so those are kind of the two ways it can go, either smaller, less than a year, or bigger than a year, then we might have to do a calculation to find the annual equivalent rate, the equivalent rate that would be charged annually that would give the same amount of interest. That's kind of the idea, that's where it comes from. And in order to do this, we have two different kind of equations we can set up. So we set them up so that the final value will be the same, that value f, and then we equal the equations and solve for that unknown rate. So you can see here the few that we've set up. So if I had a rate, for example, say this rate or, and this is the rate for a month, this is a monthly rate, then what I would want to do is I would want to put the time as 12 months, because 12 months is the same as 1 year, and I is my rate for 1 year. So I is my rate for a year. So if I want my time for related to I to be in years, then I have to make the left hand side equivalent to 1 year so that I can match them up. Now I could have done 24 months and 2 years, and you could match them up that way. So long as they were the same, then we would solve for I or solve for or, whichever we're looking for. Same thing with the next part. I've said that or is the rate for a week, so that's my weekly rate. So 52 weeks is the same as 1 year. Then for the next part, it's slightly different because what we're looking at is bigger than a year. And we're told maybe in this one that or is my rate for 8 years. That's an 8-year block. So we're maybe told at the start, you put it in for 1 year. At the end of it, this is the interest after 8 years. So for an 8-year block, this was the rate. And one block of 8 years is going to be the same as 8 years, okay, at the yearly rate. So we always have to have them equal to each other. Now another way to do that is to take the final value as a percentage relative to my original value, and then use my formula to express the time in years. So that works kind of well when we have maybe longer than a year. So maybe that last example, that can work quite well as well. And we'll see that in one of these examples here. So calculate the AER, the annual equivalent rate, on an investment which has a return of 30% after 6 years. Okay, so using what we've said in that first part there, the rate for this length of time, so this one block of 6 years, is going to be the equivalent of an annual rate over 6 years. Okay, so on the left hand side, this rate or is the rate for a full 6 years. So as in, it's if I take the amount I put in, I get the percentage of it and add it on, that's what I have at the end of 6 years. So this rate is for 6 years, one block of 6 years. And that's the same as my annual rate, my I, being charged over 6 years. So following that on, we know that the rate here is 30%, which is 0.3. And that's equal to 1 plus I to the power of 6. So 1.3 is equal to 1 plus I to the power of 6. Then I need to do kind of the sixth root, if you like. And obviously the square root is the same as 1 over 6. 1 plus I. And we can work this out. Minus 1. So I is equal to 1.3 6 minus 1, which is 0.45. 0.45. Now the other method we have is that the return is 30%. So that is 30% more on what I put in. So if I put in 1, I get 1.3. Or if we think about it in percentages, if I put in 100%, I come out with 130%. Okay, that's the idea. So what I want is my final value should be 1.3. My original value is 1, so I'm using oh, sorry, I'm using here my original formula. Let's rub that out again. So I'm using my original formula here, which is our f is equal to p1 plus I to the power of t. My final value has to be 1.3 times my original value, which we'll just say is 1. 1 plus I, we don't know what I is, and we're saying it's over 6 years. And what we can see here is actually we get to the same point that we were in on the left-hand side fairly quickly. So either way, we end up really doing the same sum fairly quickly, which is 0.45. So either way, same answer, but the key thing is whichever you choose, the left or the right hand side, you have to set it up appropriately. The left hand side is maybe more consistent because it'll be consistently the same no matter whether it's less than, greater than, whatever it is. This right hand side one can maybe be a little harder to negotiate with some other types. For example, this one, then a credit card company advertises an interest rate of 4% per month. Find the AER. So the rate per month is 4%. And obviously, if I take 12 months, that's the same as 1 year. So 1 plus 0.0, now 4% obviously is 0.04, so we have to be careful with that. The power of 12 is 1 plus I, power of 1, okay, making sure, yeah. So that's 1.04 to the power of 12 is equal to 1 plus I. I is 1.04 to the power of 12. So 1.601 minus 1. So I is 0.601, which again is around about 0.6. Okay, so around 0.6. Okay, so continuing on. So the key thing there is following those steps as best we can. Okay, so 4% per month is 0.04. We're charging that for 12 months then. So 1.04 to the power of 12, giving me that answer there, then taking away that 1 obviously to work out our final value, so I being 0.6. Then an investment bond gives 20% interest after 8 years. Calculate the AER for this bond. So this is how it could come up in an exam. Now this is from a sample paper, but it's just to give you an example of how it could come up. An investment bond gives 20% interest after 8 years. Calculate the AER out for this bond. So this is like that first type that we had. So we have the two ways that we can kind of approach it. So what we're looking at is that I have this rate, and my rate is 20% for one block of 8 years. Okay, then my other rate I is for a time of 1 year. So setting this up, 1 plus or to the power of 1 block is the same as 1 plus I over 8 years. Okay, so those are comparable. So my rate or is for 8 years, my other rate is just for 1 year, so I have to put it to 8 years to have it equal. Then we'll sub in that rate, so 20% is 0.2, 1 plus I to the power of 8. Okay. And I is 1.2 to the power of 1 over 8 minus 1, 1.2 to the power of 1 over 8 minus 1, and that gives me an interest rate of 0.023. If we try it the other way, again, we get the same thing. My final value is going to be 1.2, where my original value is 1, because it has to be 20% more. So 1.2 is 1 by 1 plus I. So we can see that no matter which way we take it, whether we do left hand side or right hand side, we're getting the same sum. We're ending up with the same answer each time, 0.023. So it doesn't matter whether we go left or right. I'm taking a quick flick through the rest of the notes, doesn't help. But either way, we're getting the same answers. So whichever way makes more sense to you, I suppose. The left hand side maybe is more consistent, but the right hand side might make more sense to some people. But it's a good one to have in your back pocket.